Hello everyone, welcome back to the channel. Today we're diving into one of the most mysterious and groundbreaking defense projects happening right now, Israel's secret sixth-generation fighter engine breakthrough. For years, major powers like the United States, China, and Russia have been pushing the boundaries of next-gen air power, but very few people expected Israel to be developing an engine concept that could potentially leapfrog an entire generation. Yet that is exactly what recent leaks, defense reports, and expert analyses suggest. Israel may be building an engine capable of powering a true sixth-generation fighter, with unprecedented thrust, thermal efficiency, and stealth performance far beyond anything flying today. The foundation of this story begins with Israel's long experience in aviation innovation, where necessity shapes technology. Israel has been surrounded by rival air forces and missile threats for decades, which pushed the country to develop aircraft upgrades, avionics, and weapons that often outperform larger nations, but an engine breakthrough is different. Engines are the hardest part of any fighter program. They require extreme temperature resistance, advanced metallurgy, and precision engineering that usually only superpowers can afford. Which is why the idea of Israel secretly working on an engine that could compete with or even surpass the world's leading projects is so surprising. Several defense insiders believe this project began as early as 2016, when Israel quietly began investigating adaptive cycle engines. These are engines capable of adjusting airflow depending on flight conditions. At low speeds, the engine increases bypass air to improve efficiency and range. At high speeds, it lowers bypass air to generate maximum thrust. This technology is extremely difficult to build, but if mastered, it creates a fighter that can supercruise at high speeds while also flying extremely long distances without refueling. For a nation like Israel, which operates in a region with long-range missile threats and large geographic challenges, having this capability would be a massive strategic advantage. The new Israeli engine concept may be based on a tri-cycle adaptive system, which goes further than the U.S. Air Force's variable cycle engine program. A tricycle system adds an additional airflow path to improve cooling, allowing the engine to operate at much higher internal temperatures. Higher temperatures mean more power, more speed, and better payload capacity. The real challenge is creating materials that can survive those temperatures. Israel has been developing ceramic matrix composites for thermal protection for years, primarily for missile applications. It now seems that these materials could be used inside a next-gen fighter engine. Another reason analysts believe the breakthrough is real is because of Israel Aerospace Industries' sudden expansion of turbine research facilities. Quiet but measurable increases in infrastructure investments, patent filings, and industrial contracts suggest a large-scale propulsion project has been underway. Unlike aircraft frames, engine programs leave distinctive economic footprints. Specialized tools, precision robotics, and high-temperature test chambers all indicate something major has been cooking behind closed doors. The secret engine is rumored to support ultra-stealth operations as well. Traditional engines produce infrared signatures that make jets vulnerable to IR-guided missiles, but sixth-generation fighters must drastically reduce heat emissions. Israel may be using a distributed exhaust cooling system, splitting the exhaust into multiple smaller flow channels. This allows the heat to dissipate more efficiently, making the aircraft appear much cooler on sensors. Combined with radar, absorbent materials, and internal weapons bays, this would create a jet that can disappear even from advanced tracking systems used by rival militaries. Another possible element of Israel's breakthrough is electromagnetic airflow control. Instead of relying solely on physical turbine blades and mechanical adjustments, the engine could use electromagnetic fields to manipulate airflow at high speeds. This allows for smoother airflow, reduced turbulence, and increased stability in extreme maneuvers. While this technology sounds futuristic, several research institutions worldwide have been experimenting with plasma-based airflow systems. If Israel first integrates such a system into a functional engine, they could achieve performance levels far beyond traditional engines. There are also theories that the new engine is being designed to support sustained hypersonic bursts. While not full hypersonic flight, the engine might allow the jet to reach near Mach 4 speeds for short periods. This capability would be invaluable in operations where outrunning enemy missiles or reaching distant targets quickly is essential. It is no secret that Israel has been developing hypersonic missile interception systems, and pairing such capabilities with a fast-reacting sixth-generation jet would reshape air dominance in the Middle East. One of the biggest advantages of this engine breakthrough would be operational flexibility. If adaptive engines can adjust performance on the fly, Israeli pilots could switch from long-range patrol mode to high-thrust combat mode instantly. This eliminates the need for multiple aircraft types for different missions. One jet could perform air superiority, strike missions, electronic warfare, and reconnaissance simply by altering engine operation and onboard systems. Such versatility would greatly reduce maintenance costs and increase Israel's ability to respond to threats swiftly. Another critical aspect is fuel efficiency. Traditional fighter jets consume massive amounts of fuel, especially during afterburner operations. Adaptive engines can generate high thrust without engaging afterburners as often. This would allow Israel's future fighter to fly farther, strike deeper, and stay in contested airspace longer while reducing vulnerability to enemy radar. For a small country that often relies on precision, efficiency, and rapid operational cycles, this is a game-changing advantage. Many experts also believe that this engine could be designed to integrate with next-generation electric and hybrid propulsion systems. Hybrid propulsion allows parts of the aircraft systems to run on stored electrical energy, reducing heat signature and noise. It also allows for silent approaches, which can be decisive in covert missions. Israel has a deep history in advanced battery research and AI-driven energy management systems. If these were combined with a sixth-gen fighter engine, it would create an aircraft capable of quiet infiltration, rapid acceleration, and sustained long-range engagement. It is also likely that AI plays a major role in controlling the new engine. Sixth-generation fighters will rely heavily on onboard AI to optimize thrust levels, manage cooling systems, and respond instantly to combat conditions. Human pilots cannot manually adjust systems fast enough during high-speed engagements. AI can make thousands of micro adjustments per second. Israel has been a leader in military AI integration for years, so incorporating this technology into a next-generation engine would be consistent with their strategic approach. Another key factor is maintenance. Engines are the most expensive part of fighter jet upkeep. Israel appears to be developing a modular engine design, allowing individual components to be replaced without dismantling the entire system. This dramatically shortens repair times. Given Israel's need for rapid operational readiness, a modular sixth-gen engine would allow damaged jets to return to the skies faster than enemy forces expect. Even with all these theoretical features, the most intriguing mystery remains: why has Israel been so quiet about this project? Unlike the U.S. or China, Israel rarely announces classified engine programs. Most of what we know is pulled from industrial patterns, research activity, and statements by defense leaders hinting at major propulsion advancements. Some believe Israel wants strategic ambiguity to keep adversaries guessing. Others think Israel may be negotiating engine partnerships with allied nations, and revealing too much too soon could disrupt those plans. There are also suggestions that Israel may want to integrate this engine into a multinational sixth-gen fighter program similar to the U.S. UNGAD or Europe's FCAS, giving Israel a leading technological role. The future implications of this engine are enormous. A sixth-generation Israeli fighter powered by this breakthrough could reshape Middle Eastern air superiority. It could outperform 4th Gen and 5th Gen adversaries with overwhelming ease. It could strike distant targets without refueling, avoid modern air defenses, and engage enemy aircraft before being detected. It could also act as a command hub for drones, hypersonic interceptors, and autonomous combat systems. With such an engine, Israel would not just be upgrading its air force, it would be rewriting the rules of aerial warfare. For enemies relying on mass production or older technologies, a sixth-generation Israeli fighter would be almost impossible to counter. Speed, stealth, efficiency, and electronic dominance would give Israel unmatched control of the skies. It would also strengthen Israel's deterrence doctrine, reducing the likelihood of large-scale conflicts by raising the cost of aggression beyond what enemy nations could handle. As we move closer to 2030, more details may leak out. Satellite imagery might catch glimpses of prototype testing. Defense budgets might reveal unusual allocations. Engineers might accidentally reveal hints during conferences. And eventually, Israel may announce the existence of a prototype aircraft powered by this revolutionary engine. But until that moment, the world watches and speculates, knowing that when Israel develops something in secret, it is rarely small. The story of Israel's sixth-generation engine breakthrough is still unfolding, but all signs point to a transformative development. A propulsion system unlike anything Israel has built before, a leap into future air combat, and possibly the beginning of a new era of aviation technology that will influence allies and reshape military balance worldwide. Thank you for watching, and if you want more deep dive analyses into future military technology, make sure to like, subscribe, and stay tuned for the next video.